In 2012, I took part in an interview for Great Minds, a program produced by the Educational Broadcasting System in South Korea. It was an engaging opportunity to discuss science, rational inquiry, and the evolutionary perspective on life. What follows is a segment of that conversation. I hope you find it thought-provoking. I'm Richard Dawkins, Emeritus Professor of the Public Understanding of Science at the University of Oxford. All the wonders of life, all the elegance, all the illusion of design stems from natural selection. They have purpose written all over them. They seem to be designed. They seem to be designed by a master craftsman who foresaw what would be necessary. And this comes about through Darwinian natural selection. Random mutation means random changes in the genes. Most of the random changes in genes are deleterious. They're not good, they're bad. They don't favor survival and reproduction. A minority of them are good. A minority of them do lead to improved survival and reproduction. And those are the ones that do survive. Sort of pretty obviously, really. Those are the ones that do survive. And that is natural selection. Darwin led up to this in his explanation of this via domestication. It was already well known. People knew, farmers knew, horticulturalists knew, animal breeders knew, pigeon fanciers knew, dog breeders knew that you can influence changes in breeds of dogs or types of cabbages or types of roses or types of cats or cattle or pigs by artificial selection, by choosing which ones to breed from. And that's been known for thousands of years, and it's a powerful technique. When you think that a dog like a Pekingese or a poodle or a Yorkshire Terrier or a bulldog is really a wolf that's been bred by humans over a period of just a few centuries. If that can be achieved in a few centuries, think what can be achieved in millions of years. And what Darwin realized was that you don't need a breeder. You don't need a human selector to choose to breed from this rather than that one. All that's necessary is that some survive better than others. Some are more successful at getting a mate than others. So they are the ones who breed. They are the ones who pass on the genes. So as the millennia go by, as the millions of years go by, animals get better and better at the art of surviving and reproducing. So the raw material for variation is provided by random genetic mutation, random genetic change, mistakes in the copying of DNA. But it's non-random survival of genes, which leads to evolution in the direction of better survival and better reproduction. And so what geneticists actually study is mutations of large effect. However, those are not the important mutations in evolution, because mutations of large effect are highly likely to be deleterious. And the reason is that if the animal already survives pretty well when it has children, then a large mutation would mean that the child was very different from the parent. And since the parent has already survived well, it's unlikely that a major change from the state of the parent would be good at surviving. So small mutations are the ones that are important in evolution. One of the pioneers of Darwinism in the 20th century, Ronald Fisher, R.A. Fisher, who was a very important figure in the development of the theory, he used the analogy of a microscope. He pointed out that a microscope needs to be in focus, and it can either be the objective lens of the microscope might be either too high or too low. But if it's almost in focus, then only a small change in the height of the tube of the microscope is needed, either in the upward direction or the downward direction. a large change is bound to be worse. Either it goes miles out of focus this way, or it crashes through the slide that way. So only a very small change is likely to be beneficial. Fisher pointed out that the smaller the change, the more it approaches perfection. You would expect on the evolution idea that things will not be perfect, because after all, natural selection has to work on what's already there. It's not like an engineer who can throw away the existing design, toss it away and go back to a clean drawing board. When the jet engine was first invented, the designer of the jet engine, it's a bit disputed who that was, as the various candidates, did not have to work by modification step by step from a propeller engine. Imagine what a ridiculous jet engine he would have produced if he'd had to change a propeller engine into a jet engine, step by tiny step, moving a screw here, a rivet there, changing little bits of it. You couldn't do that. You throw it away and you start again. So the equivalent of a jet engine cannot be done by starting from scratch. It has to be done by gradual change from what's already there. There's something like, the lung, for example, which we all breathe with lungs. Well, fish have something equivalent to a lung, like the swim bladder, which is used as a buoyancy control. So the lung comes from the swim bladder. It doesn't come from starting with a clean drawing board. So there has to be imperfection. Now, there are some beautiful examples of imperfection. One of them, for example, is a flatfish, like a sole. A flatfish like a sole or a halibut or a plaice lies on its side, and so one of its eyes is looking down into the sand, which is useless. And so natural selection has favored the migration of the eye round to the other side. And so those fish have both eyes on the same side of the head, like a Picasso picture. And now this is an obvious imperfection, but it had to be, it's the only way it could happen. Another example is the laryngeal nerve of, us, for example, but all mammals and reptiles and birds. The laryngeal nerve is a nerve that goes from the brain, is one of the cranial nerves, from the brain, and it goes to the larynx, the voice box. But it doesn't go straight to, one branch of it goes straight to the larynx. Another branch goes down into the chest, loops around one of the main arteries in the chest, and then goes straight back up to the larynx, which is a detour, a ridiculous detour. It shouldn't do that. I've assisted in the dissection of a giraffe's neck, specifically for this purpose. And we watched this nerve, we traced this nerve going down the giraffe's neck, passing within a couple of centimeters of the larynx, going straight past the larynx, down into the chest, going many meters down into the chest, and then back up again to the larynx. And you feel how ridiculous. Any designer would have sent that back. Any designer would have refused to allow that to pass through quality control. It whizzes straight past the larynx and then goes down and back up again. An absurd piece of bad design. And the reason lies in history. The reason lies in the fact that in our fish ancestors, that particular nerve, what we would not call the laryngeal nerve then, there was no larynx, but nevertheless, the equivalent of that nerve did go behind the artery, and that was in those days the most direct route. And then later on, as our fish ancestors gradually evolved on land, fish don't have necks, we do. As the neck evolved, the detour of the nerve going round the artery was a rather slight detour to begin with. And then as the neck lengthened and lengthened and lengthened and lengthened, the marginal cost of jumping that nerve over the artery was too great. It would have been a major change in embryology. And so at each stage of the lengthening, the cost of lengthening was negligible. And so the explanation for the bad design lies in history. Another very good example is the retina of our eye, which is back to front. You know, our eye is a set of photocells looking out at the world. And instead of the photocells pointing out towards the world, they point backwards. And the wires, the nerves that connect the photocells to the brain, therefore have to find their way around the retina. They go across the surface of the retina, and then they dive through a hole in the retina, which is called the blind spot, into the optic nerve. A ridiculous piece of bad design. The great German physiologist Helmholtz said that if he had been handed the eye designed by an engineer, he would have sent it back. Why do perfection and imperfection coexist? Well, imperfection is really a necessary part of the way evolution works because of costs. I've talked about the most obvious examples, like the retina being backwards and the recurrent laryngeal nerve and the flatfish eye being twisted sideways. But really, all Darwinian design is a compromise between relatively incompatible pressures. Natural selection can be thought of as a whole lot of pressures pushing in different directions. So, for example, the need for a male bird to be brightly colored to attract females is pushing him in the evolutionary direction of being brightly colored. At the same time, however, predators are also attracted by bright colors, and so that's pushing in the opposite direction. And so, from the point of view of sexual attractiveness, bright colors would be ideal. I mean, the brighter the better. But from the point of view of avoiding predators, bright colors are bad. So it's a compromise. And not just compromise between different selection pressures like sex and predation, but also economic costs. Nothing is free. There's no such thing as a free lunch. So everything costs something. And economics is very important in evolutionary theory.